Good afternoon. This is Professor David de los Reyes. My topic this afternoon will be computation of area. This is under integral calculus involving polar equations. Okay, let's proceed with the topic for this afternoon. This is now my lesson 56. Polar coordinates, computation of areas. Okay, I will give you a very nice problem, guys. I will read the problem. Find the area enclosed by the polar equation. The polar equation is R equal to 3 minus 2 sine of theta. We are asked to solve for the area enclosed by this polar equation R equal to 3 minus 2 sine of theta. First requirement under polar coordinates, we should visualize what kind of figure is this one. And to verify actually the actual graph of this one is actually, we use the so-called point plotting. It's a very tedious process, but after taking the values of theta, sine of theta, and r, we could visualize what will be the figure of the given polar equation. Okay, let's proceed. It is something like this, guys. We got 3 columns over here. The first column is theta, second column is sine of theta, the third column is the value of the radius. What will be the significance of theta, sine of theta, and r? We will relate theta, sine of theta, and r back to the given polar equation. Okay. For the first column, we place the value of the angle. We will complete a complete 360 degrees. So it will be 0 degree, 30, 45, 60, 90, 120, 150, 180. We will continue to 210 degrees. I am increasing the angle by an increment of 30 degrees. 240, 270, 300, 330, and 360. So I place the value from 0 to 360, so we could visualize what kind of equation or what kind of graph is this. Then second column, sine of theta, 0.5. Okay, I will give you how come it come out like that. Okay, wait guys, I will get my calculator. Okay, I'm back. So actually, for this point plotting to be good enough for us, we must have to use our scientific calculator. If angle theta is 0, sine of theta for this first part over here, I said the value of 0. And I said the value of the radius is 3. How come it comes out like that? For the given polar equation, if theta is 0, sine of 0 will be 0, 2 times 0 will be 0, okay? 3 minus 0 will be 0, will be 3. So the meaning of this, when theta is 0, sine of theta will be 0, and the radius at that time will be 3. Okay? We can graph this one now. This is 3. Okay. At 0 degree, the value of the radius is 3. At 30 degrees, okay, sine of 30 will be 0.5. Okay. 0.5. 2 times 0.5 will be 1. So 3 minus 1 will be 2. So when theta is 30 degrees, sine of theta will be 0.5, and the radius at that time is actually 2. It's 2. It's here. Then so on. At 45 degrees, the value of the radius will be this much here. At 60 degrees, the value of the radius is this much here. At 90 degrees, the value of the radius is 1. Why 1? Sine of 90 is 1, 2 times 1 is 1, 3 minus 2 is actually 1. At 90 degrees, the radius of the given polar equation is actually 1. It is this. Then as we increase it, at 120, it will become 1.268 again. At 150, it will be 2. It will be 2. And at 180, it will be 3. Okay? 3. This is 3. 3 and 3. So actually, we could visualize now, it seems that the resulting polar equation is actually symmetrical with respect to the vertical line. Then as we continue it, at 210, the value of the radius will be 4. At 240, the value of the radius is 4.732. And at 270, the value of the radius is 5. 1, 2, 3, 4, 5. So this is 5 units. Okay. Then at 300, it is 4.732. And at 330, it is 4. Then at 360, it will go back to 3. Okay. It will go back to 3. So actually, the resulting polar equation, after the point plotting, what comes out is actually a heart shape. Okay. And it is symmetrical with respect to the 90 into 70 degree line, or just simply the vertical line. So actually, to compute for the total area of this, we will now draw a differential over here. We should move this differential area from this angle here. We rotate it clockwise till it reaches 90 degrees. So the limit is actually from 270 to 90 degrees, moving counterclockwise to complete half of the area. And in terms of radians, 270 is minus 5 over 2. And the final limit is actually 5 over 2. 90 degrees is 5 over 2. Why this is negative? It is on the fourth quadrant. It should be a negative angle. Why this is positive? It is on the first quadrant. It is a positive angle. So our limit is actually from minus 5 over 2, from this line here up to this, if we try to rotate the polar area. Okay? So after the point plotting, what comes out is a heart shape, and it is symmetrical with respect to the 90 degree and 270 degree line, or in terms of the Cartesian, it is symmetrical with respect to the vertical line. Okay? Let's bring out the solution of this now. Under polar coordinates, differential area is equal to 1/2 of r squared differential theta. Right? And we are given the polar equation. The polar equation is 3 minus twice sine of theta. We need an r squared inside for us to integrate. Since r is equal to 3 minus twice sine of theta, squaring both sides. Okay? R squared now will be the square of the first one, it is 9. The middle term is actually 3 times minus twice sine of theta times 2, so that it is minus 12 sine of theta. The third term is actually the square of minus twice sine of theta, quantity square, it will be 4 sine square of theta. Equation number 1. Why I mark it as equation number 1? If we try to substitute this one to this equation here, this part is not yet integrable. So we must have to convert this sine square of theta in terms of a double angle, not a square function. Because a double angle is integrable, but a sine square function is not integrable. Since cosine square of theta is equal to 1/2 times the quantity 1 plus cosine of 2 theta, okay, we will replace this one in terms of a double angle, which will become integrable. What is cosine square of theta? It is 1 minus sine square of theta, equal to, we expand the right hand side, this is 1/2, plus 1/2 cosine of twice theta. If we try to simplify this one, sine square of theta in terms of a double angle is actually 1/2 minus 1/2 cosine of twice theta. And upon reaching the integration process, we can integrate cosine of twice theta. Okay, there is a formula on how to take the integral of a cosine function, but not for a cosine square function. So we will take this value here, we place it on equation number 1. Therefore, r square now is equal to, we are following this, 9 minus 12 sine of theta plus 4 times the equivalent of sine square of theta in terms of a double angle. This is 1/2 minus 1/2 cosine of 2 theta. And upon simplification, r square is actually 11. Why 11? 4 times 1/2 is 2. 2 plus 9, that will be 11. Minus 12 sine of theta. Okay? 4 times 1/2 will be 2. The coefficient of cosine of 2 theta will be 2 cosine of 2 theta. So actually, this is now a very safe function. Sine of theta, cosine of theta, upon reaching the integration process, this is integrable, this is integrable. Okay? That's the reason why I replace cosine square of theta in terms of a double angle. Okay. Differential area over 2, why area over 2? We use symmetry. To compute for the total area, just take half of the area, you rotate it from minus pi over 2 to pi over 2, then times 2. So differential area over 2 equal to 1/2. We are following this. What is r square? R square from our previous computation is 11 minus 12 sine of theta minus twice cosine of theta close quantity differential theta. We are following this, right? Okay. Integrating both sides. Okay. The integral of the differential area will be the total area equal to what will be our limit now? It will be from minus pi over 2, negative 90 degrees, measure clockwise, up to 90 degrees, measure clockwise. So our limit is actually from minus pi over 2 to pi over 2. Okay? So this is now with the integral from minus pi over 2 to pi over 2 of the quantity 11 minus 12 sine of theta minus twice cosine of theta. Okay? This is integrable, this is integrable, this is integrable. But we must have to verify the values of the differential thing in each of the terms. Integral of sine is actually plus cosine, right? But let's verify the value of u. For sine of theta, u is theta, differential u is actually differential theta. It is exact. 12 sine of theta, differential theta, it will be a complete differential, right? For the second, third term, the double angle, the angle is actually twice theta, du will be twice differential theta. So actually we are missing 2 over here for the third term. Okay? I will erase this, guys, so you can see it. We've been through this the last time around. So if we try to integrate 11 differential theta, we take the integral, that will be 11 theta. Okay. This one will be minus 12. Okay. The integral of sine is minus cosine, so this is minus cosine of theta. Okay. This one will be minus 2. But we are lacking 1/2 outside, so we place 1/2. Okay? And the integral of cosine of 2 theta is sine of 2 theta. With the limit from minus pi over 2 to pi over 2. So actually this will become 11 theta. Minus minus, this will now be plus 12 cosine of theta. Okay? This cancels out, minus sine of 2 theta. And this is with the limit from pi over 2 to negative pi over 2 to pi over 2. It is this. Okay? I will erase this one, guys. So you can see our simplification because I expedite our solution over there. If we now try to place the upper limit, 11 times theta will be 11 times pi over 2. Okay? Plus. If this theta here is pi over 2, 90 degrees, take the cosine of 90, it will be 0. 12 times 0 will be 0, so this is actually plus 0. The third term, using the upper limit, 2 times pi over 2 is actually pi. This will become pi, right? 180. The sine of 180 is 0. So this is actually now minus 0. Minus open quantity. 11, we are following this, right? 11, if we try to place the lower limit, this will be times minus pi over 2. Right? Plus 12. Negative pi over 2 is negative 90 degrees. And 90 degrees equals cosine of 90 is 0. So much more the cosine of negative 90 will be 0. So this will become 0. 0 times 12 will be 0. So this is plus 0. Even the double angle, this will become, okay, phi. Okay? Or negative pi, negative 180. Plus 180 or minus 180, the value of its sine value is actually 0. So this is minus 0. Okay? So this will be, sorry for this one, this is 11. 11 times pi over 2 plus 0 plus 0 minus 0. This is minus minus, this will become plus, right? Plus. Oh, this is actually 11, guys. 11. 11 times pi over 2 minus 0 plus 0, okay? So, how come I am writing pi over, this should be 11. These are similar terms, right? So this is 2 times pi over 2. 2 times 11. So these two here cancel with this. So our answer is, this should be 11. Okay. 11 times pi. Area. Square units. This one here is this. So the area covered by the given polar equation, in which the given polar equation is r is equal to 3 minus twice sine of theta, is actually 11 pi square units. It's a heart shape, guys. And that is the total area. This is 270 degrees, this is 90 degrees, this is 0 degree, this is 180. This was the graph obtained by using the point plotting. Okay, that's it, guys. The complete solution of the area bounded by r equal to 3 minus twice sine of theta. So the significance of the point plotting is that we could visualize the graph and we could determine what will be our lower limit and upper limit upon reaching the integration process. Okay, good afternoon, Los Angeles.